Hey, how's it going? Master Cow here, and I'm here with another video, another math tutorial for the AA Discord server, and I'm going to be talking about function operations. Functions, you can do whatever you can do to regular numbers or variables you can do to functions. You can add them, you can subtract them, multiply, or you can divide functions. You can do any of those. There's also another type of operation as well called composition. And composition is where you have two functions, f of x and g of x. And basically, one of the functions will be the input of the other function. So you write it as f of g of x, or if you want to do the other way, you do g of f of x. Now note that those are two different operations. They're not commutative, and you will most likely get different results for that. And giving you in a brief example, let's say we have f of x is equal to x plus 3, and we have g of x is equal to x squared minus 4. If I wanted to find f of g of x, wherever I would plug this into here. So I would plug in x squared minus 4 in for x, and then I'd have the plus 3 at the end. So simplifying that, that becomes x squared minus 1. If I were to do the opposite, if I were to do g of f of x, then I would take f of x and plug it into any x in the g function. So I would wind up getting the quantity x plus 3 squared minus 4. So if I expanded that out, I would get, that would be x squared plus 6x, and then that would be plus 9. 9 minus 4 is 5, so I would get x squared plus 6x equals 5. And that's how to do function operations. So I'm going to work through kind of what a typical example would be. I believe this is Algebra 2. It might be pre-calculus, but for this set of problems, I'm going to do find f plus g, f minus g, f times g, f divided by g, and also composition. Another way to write composition is with this open circle. This means you compose them. F composed with g and g composed with f. And for each of those, find, and for each state the domain and range of the resultant functions. So, and what I'm going to do, I picked somewhat of more challenging just to illustrate some things with domain and range. I picked f of x to be natural log of x plus 3x squared, and I picked g of x to be 3 times the square root of x minus 5, and then that minus 4. So first we'll do f plus g. That we just combine, and there aren't any like terms, so we can just write it out. Natural log of x plus 3x squared plus 3 times the square root of x minus 5, and then minus 4. For f minus g, again, same thing, there's no like terms, so we just list them all out. Or not like terms, like terms. Natural log of x plus 3x squared, and then I do minus, this becomes minus 3 square root of x minus 5, And be careful here, I'm subtracting the entire function, so this is minus minus, which turns into plus 4. And then if I were to multiply the functions f times g, I would get natural log of x plus 3x squared times the quantity 3 square root of x minus 5 minus 4. And so if I wanted to FOIL that out, I would get 3 square root of x minus 5 times natural log of x minus 4 natural log of x and then that would be plus 9x squared square root of x minus 5. And then finally, minus 12x squared. And not really any other common factors, so I'll just leave that as it is. And then for f over g, I would get natural log of x plus 3x squared divided by 3 times the square root of x minus 5, and then minus 4. And now for the compositions. So first we have f composed with g. So this means I take g of x and I plug it in wherever I see an x. And there are 2 x's in this case. So this becomes natural log of 3 square root of x minus 5, and then minus 4. And then I have plus 3 times 3 times the square root of x minus 5 minus 4, all squared. And I could square that out. It would turn out to be some messy trinomial, the square root terms. So, and then if I go the other way, g composed with f, notice here that there is only one x, so I only need to plug in at one spot. So I get 3 times the square root of, in this case, it's going to be natural log of x plus 3x squared minus 5, and then minus 4. So now domain and range. So, so D and R. So we'll start with A. So, and just a reminder, the domain is what you put into the function, and the range are the values you can expect to put out of the function. So for f of x, or for f plus g, so here we have natural log, and natural log does have a domain restriction. You cannot take the natural log of 0 or of anything that is less than or equal to 0, and that is because the definition of natural log, you're raising e to some power and you're getting a number, and you cannot raise e to any number and get a negative result. And you cannot raise e to any power and get 0. That's true for every non-zero positive number. You cannot raise it to any power, positive or negative, and get an output of 0 or a negative number. So automatically, you can say that x must be greater than 0. 3x squared has no restrictions. You can plug whenever you want. Square root also has a domain restriction. You cannot take the square root of a negative number because it has no real answer. You get imaginary answers. And so in this case, here, x cannot be less than 5. Because if you plug in 4, you get 4 minus 5, and you have the square root of negative 1, which is not defined in the real set. So when you put it all together, the domain is x has to be greater than or equal to 5 in order for it to make sense. And then the range, well, with natural log, you can get positive or negative results, because you can get infinitesimally, or well, actually no, yeah, because you can get infinitesimally small. That you can get anything. Square root has to be positive, so you can assume for this you can get any real number. So infinity to infinity, you can get any real number. So now for B, subtracting. And subtracting is the same term, so it's the same rules. This cannot take anything that's less than or equal to 0. This cannot take anything that's less than 5. So the domain is the same. X has to be greater than or equal to 5. And it's the same thing for the range. This can go anywhere from infinity to negative infinity. Same thing for that. This thing can go from 0 to infinity, and then 4 is just a little add-on there. So the range is also all real numbers. Part C, the multiplication of these. So this becomes a bit more complicated here. So again, here, the x minus 5 under the square root must be greater than or equal to 5. Times natural log of x, well, again, you can't plug in a number that is less than 0. That's the same thing. So the domain for that is still the same. It's x is greater than or equal to 5. And as far as the range goes, that could be anything. Well, yeah, that can be anything. This can be anything. That can be. Now this has to be a positive number because you have a positive number, and then this is a principal square root. So that's positive, and then that's also positive, but you're subtracting it, so that's also infinity to negative infinity. And now for part D, so division. So it's the same terms, but there is one more thing you have to be aware of. There's one more domain restriction. You cannot have a 0 in the denominator. So let's work out on the side. So let's set 3 square root of x minus 5 minus 4 equal to 0. So that becomes 3 square root of x minus 5 is equal to positive 4. Divided by 3 square root of x minus 5 is equal to 4/3. If I square both sides, I get x minus 5 is equal to, that would be 16 over 9. If I add 5 to both sides, a common denominator, so I need to get 45, so I get 16 times 5 over 45. Okay, so I fixed my mistake there. I was supposed to plus there, and then I'm also supposed to times by 45. And so what I wind up getting is I get 305 divided by 45, which will wind up reducing to 61 over 9. So this means that x equals 61 over 9 is not a valid solution either, so it means that x must be greater than or equal to 5, and 61 over 9, that is greater than 5, and x cannot be 61 over 9. And I also have infinity to minus infinity. Whoops, minus, minus, minus. All right, so lastly now we have to do part E and part F, which was the function composition. Let me add a little bit more room here. Okay, so these obviously are more complicated. So here we have natural log of this whole thing here, and then that. So, and again, we got to remember those rules. So in this case, x cannot be less than 5. So xs must be greater than 5. But this whole thing cannot be equal to or less than 0. So let's plug that whole quantity in. Well, we already solved that actually right here. We did this work. So this happens to have the exact same domain restrictions as this one. It cannot be 61 over 9, and it cannot be less than 5. And then over here, again, the square root, it means x cannot be less than 5. Everything else should pretty much be taken care of, though. The domain for this one is that x must be greater than 61/9. because if x is equal to 61/9, then this whole thing is 0, which is undefined. Anyways, back to the range part. Well, the square root will wind up being some the square root will wind up being some positive number. That will be some positive number. And so when I take the natural log of that, well, if the natural log is less than 1, it's going to be a negative number. If it's greater than 1, it's going to be a positive number. Because the smallest value I could get natural log of like the smallest value that's greater than 0. And so that would still be practically negative. That would be negative infinity. And then over here, this is a positive number. So over here, this is a positive number. So that becomes positive. I subtract that, regardless of which it will turn into a positive number. So I wind up getting some positive number, and so it will end up being infinity. It's a negative infinity. So part F. So for part F, G composed with F. So here we have a more complicated square root. Here we have natural log of x plus 3x squared minus 5. Well, right away we know that x cannot be less than or equal to 0. So that automatically makes that undefined. So we have to set that equal to 0. So we have natural log of x plus 3x squared minus 5 is equal to 0. So I get natural log of x plus 3x squared is equal to 5. So this one we may have to do more intuitively. So again, here I cannot plug any negative number in here or 0, which automatically by domain restrictions, which is fine because this will automatically be some positive number, and then this here will be there probably is some solution to this, so I'm going to pull up Desmos and see if there's a solution to that. Okay, so I plugged it in here, and this value here, 1.261, is where it's equal to 0, and thus therefore, and thus is where it's equal to 0. And so that means any value that is less than that, so any value here makes that function undefined. So that's the only domain restriction here. X must be greater than or equal to 1.261. And then the range, well, square root will always be a positive number, so or 0. So the smallest value of this could be a 0, which means the minimum value for this is -4, and then it goes all the way up to, and then it could go all the way up to infinity. And so yeah, that's how to compose functions, and that's how to find the domain and range of operations of functions. I hope you enjoyed this video. Leave a comment down below of any topics that you would like me to cover in future videos, and I hope you enjoy the rest of your day.